So I will continue, but if you have question, you can ask anytime, no problem. So now we will discuss just a specific application of dosimeter, which is personal dosimeter. Personal dosimeter is a small detector worn by individual or a radiation worker or who work in a radiation environment. It helps to realize radiation protection by ensure dose limit is not high or not exceed the limits. Provide documentation in radiation accident, and RSO actually need to document this, the absorbed dose for each individual worker. And this is one of the requirement of radiation protection, and one of the mission should be done by RSO. Personal dosimeter should record wide range of received dose. And I think this is, it's clear for you why we need personal dosimeter to realize the radiation protection. Okay, because we are working with radiation, so we have to keep recording everyday exposure. And we have to, for RSO or employer, to monitor this kind of level. And the ultimate goal is radiation protection. Okay. Thermoluminescence, or the famous name is TLD, thermoluminescence detector, is the emission of light from crystal on heating after removal of excitation. So here, just you can see. Here the valence band and conduction band in atom, and this is the forbidden gap, FP. So when this crystal, this is the TLD crystal, when hit by radiation, it will deposit energy, and the electron will have this kind of energy and will go up to conduction band, and it will back immediately and release light or the different energy. But we don't like this process to happen, so we need to add some dopant or other material, we call it activator or electron hole trap, to stop the electron not just directly back to the valence band, but we just trap them here in this part, and we need to release them. We will do by heating. So this is actually radiation, that as I explained. And if you wanted to use it and release the dose, absorbed dose, so you need a specific machine or reactor to release the electron from this kind of trap. Okay, so when you heat it in TLD reader, this TLD, this is exposed TLD, you will heat it, and the electron will release from the trap, so, and will produce light. This light, it will be sensed by PMT, similar machine to the scintillator one, and converted the light to electron, and will amplify the signal, and we can measure it. So the light, or the amount of light, is related to the deposit energy. Do you know, or do you have TLD? Anyone have TLD? Do you know when you should read your dose? After how many months you should wear it?
Every 3 months.
Yes, good. This is just more details about TLD. Badge include chips, different chips for different, to measure different types of radiation, neutron, gamma, X-ray, and to measure the shallow or deep dose or whole body dose. And different material can be actually used for this chip, but one of the famous material is lithium fluoride, which is tissue equivalent. And this is one of feature of TLD using this material. Dose range 0.02 millisievert to 10 sieverts, and this is one feature should be in the Persional dosimeter, wide range. TLD measure the whole body deep equivalent dose, HP10. Do you know what is mean HP10? And also TLD measure the shallow dose equivalent dose, HP 0.07. The whole body deep equivalent dose, it's the equivalent dose measure at 10 millimeter under the surface exposed to radiation. Just more explanation about this number, okay. The disadvantage or advantage of the TLD is a small size, high sensitive, tissue equivalent. It can be used many times. You can just read it and use it many times. But it has some disadvantage and drawbacks, time consuming, because it will not give you directly the exposure dose. You need to wait 3 months and you read it. Okay, no permanent record. As just when you read it, it will lose everything and you have to start from zero. Thermal fading, and this is one of issue I want to just to make sure you realize this kind of problem in TLD. Thermal fading effect on the absorbed dose in this material. When TLD exposed to heating, and you know here Riyadh, it's high temperature. So if you use it outside, I mean the personal one, indoor one, if you use it outside or you leave it in car or something, it will not measure the right exposure you exposed to. So you have to keep it at the room temperature or low temperature to avoid missing some information. Okay. This is another Persional dosimeter, which is just to start some people have this kind of new detectors or Persional dosimeter. We call it OSL, optically stimulated luminescence, which is it's almost the same TLD and the same mechanism. So we'll not talk about it more. So it's the same. But the only difference is instead of heating the TLD crystal to produce, to release the electron from their trap, you need just to use light, laser, okay? So the crystal here, it would be after, if you wanted to read it and to know the dose, just expose it to the light, laser, and you can read it instead of heating. So on TLD, we use here heating to release the electron from the trap. Instead, on the OSL, we just use the laser. And this is the kind of OSL. From its name, you can just know the mechanism, how it works. Optically stimulated luminescent dosimeter are made of the carbon doped aluminum oxide. And this is its material, similar to a TLD. And we explained that issue. Repeatedly read out TLD. When you read it, you will lose all information. I mean, when you read it, you will not be able anymore to read again the dose. So it's just one time read those. This many times you can use it. It's still new, so if you compare the accuracy between TLD and OSL, we actually need to study more to see how to figure out which one is more accurate. Okay, but TLD is still now it's more accurate than OSL. dose range, it's 10 microsieverts to 10 sieverts. It's wide range. Film dosimeter, it's really old. Okay, also it's passive detector, film dosimeter. Film badge consists of the photographic film in holder. It's kind of normal film, but it's in a specific holder with the different filter. You can see this different filter here. Okay, because to measure different type of radiation. Okay, it can measure X-ray, gamma. The holder is fitted with a range of filter, which allows to distinguish between beta, X-ray, gamma. Okay, also it will measure the whole body dose or shallow dose or a skin dose. By determining the optical, this is how to read it. Okay, when upon exposed to radiation, some part of it area exposed to radiation will turn to black, or the optical density will be changed. So here we will measure the optical density, okay, or blacking of the developed film, and we will link it to the exposed dose. So we need the reference to be able to read this kind of film. But anyways, it's not used anymore. Its energy is not tissue equivalent. So you can see the difference between the tissue equivalent lithium fluoride used in TLD and film dosimeter. And this is one of the issue. That's why we just move to the TLD. Can measure dose of radiation received from X-ray, gamma, neutron profile using the right filter. Bucket dosimeter, we can classify it as a direct detector. It's not passive detector. You can actually measure the exposure dose immediately on time. Types of the bucket dosimeter is bucket on old one. Okay, it's manual bucket dosimeter, and digital electronic dosimeter, which is the new one. This is the old one, and I think it's not used anymore, and replaced by the digital one. It can read it's kind of, if you want to just explain about how it works, it's contained the ionization chamber here, centered by anode and connected with the fiber. Okay, and this electroanode and the fiber connected to the anode should charge with the same charge, positive, for example. So it will rebuild each other. So when the ionization chamber here, in this case, exposed to radiation, the charge percentage will change. So the anode and the fiber, it will move because the charge balance changes. So you can actually read the dose. But it has drawbacks, so it's limiting range. So because of it depends on charge, the anode and fiber connected to that anode. So any potential of discharging actually, and you will lose the exposure dose. Bucket dosimeter, it's digital one, and this new one, it depends on the semiconductor. I mean the main detector inside this detector can be Geiger-Miller gas detector or semiconductor, useful at the emergency situation if you will have chance just to, to attend any place where the, for example, radiation accident happens. So you have to have this kind of detectors because you need to measure the radiation immediately. So the TLD in this case is not useful. We need just to measure quickly in addition to the surveymeter. Detectors, actually it can be changed for any reason. When you use detectors to keep this radiation detector to work well, you have to calibrate it. Before you had to calibrate the radiation detector every 6 months, but now just once a year. So, and you need to calibrate it to accredited a standard or a standard or detector, standard detector. And this kind of place you have to calibrate your detector there. It's called Standard Dosimetry Laboratory, or SSDL. We have primary and secondary lab. Primary is just in few countries, and secondary lab here in Saudi Arabia we have SSDL lab. So many companies just go there and calibrate their instrument, surveymeter, or any kind of detectors. The calibration method for the detection system is designed to ensure the integrity of the measurement made with the user dosimetry. So to realize the radiation protection, that your detector dosimeter should work well, and how to make sure your detector is working well by this kind of calibration. Any question about this part? Hello? Are you there?
No questions.
Okay. I just want to make sure you. I think you are tired now, or what? The last lecture, it will be about radiation area classification, and this one of requirement for radiation protection. Anyone can tell me why do we need to divide the radiation areas or classify the radiation areas? What is the purpose of that?
I think it's about the strength of the radiation depending on the area. How close are you to the source of the radiation?
Okay. Anyone else?
To know who can access this area. Some areas only workers can access that areas. Other for
good, but why? Why do we need to restrict the access to this kind of area?
It depends on the, the radiation and close to the source or something like that. Some area, and to know how much, you cannot access without TLD or something like that. So you know how much radiation you get there or something like that. So for public,
Okay.
some areas will be close to that area or to enter that area.
Yeah, to realize the radiation protection to prevent unnecessary exposure. Okay.
Yeah.
Okay, so do you know what is the name of different classification of radiation area? Okay, let's start there. This is the content of the last lecture, just simple introduction, and we will discuss the different radiation area, control area, supervised area, and the requirement for each area. And just a simple summary. This is a lecture, by the way, it will be light. So the purpose of classifying radiation area is to help manage the radiation risk by identifying and segregating higher risk, okay, activities from the lower, and thus controlling the radiation exposure. So you don't need to expose all your worker to radiation, unnecessary radiation. So you have to divide it area. This is the controlled area, and this is supervised area. This is area with the high exposure, and this is area with the lower exposure. So who will enter the high radiation level? There's some requirement to keep radiation, effect of radiation as low as possible. So there are two classes of working condition. This is before starting just talk about controlled and supervised area. We have to know some information. So there are two classes of working conditions for radiation worker, working condition A and B. A, where the annual exposure might exceed 3/10 of dose limit, which is 20 millisieverts. So in this case, around 6 millisieverts. Working condition B, where is the most unlikely that annual exposure will exceed 3/10 of those limits, which is around actually 1 millisievert. It may be convenient for radiation control purposes to classify radiation work according to their exposure condition. Okay, so we have work condition. So we need to classify the worker as well according to the work condition. Worker class A, these are radiation worker working under working condition A, and B under working condition B. So A, the worker who will exposed to more than or exceed 3/10 of annual dose. The employer should keep the classification of worker engaged in the radiation work under review to accommodate changes in the working practice. It should be noted that in general, there is no exact parallel between the classification of area and classification of worker in respect of their working condition, because the classification of area normally does not take into account the time spent by the worker. So, for example, in worker A, we just said they are working in work condition A, but sometimes in work condition A, it's also different. So it's not in general. You can just classify worker A in condition A. There's sometimes you have to be specific and to revise the working condition, okay, to classify people. Even people in work condition A should also classify. Some area of condition A will be, maybe will be exposed to higher risk than other, even in the same class. Okay, so we have to have this kind of sense. Well, let's start with a controlled area. A controlled area, as a definition, is the area which has been designated by the employer with RSO to assist in controlling and restricting radiation exposure. And exposure should, or it might be exceed 3/10 annual dose, which is 20 millisieverts. A controlled area is any area in which specific protection measure and safety provision are or could be required for control normal exposure and preventing exposed to high risk. Access to control area should be restricted to those workers assigned to work in this area and other whose access has been authorized by appropriate level of the management. Do you think a worker or person with the age 16 can be classified as a worker in control area? Maybe you will be asked about this question.
Can you repeat
or
that?
at least it's a, yeah. Do you think under 18 age, for example, 17 or 18 can classify it as a person or worker in controlled area? Employer can do that. If I have employee 16 age.
He cannot. If he's less than 18, I don't think he's allowed to work in restricted areas or rigs or sites or anywhere like that.
Why?
Well, I'm not
That's right,
sure why
okay.
that. I'm not sure why, honestly.
Yeah, anyone can answer.
Because I think those limits those limits for less than 18 is less annual. I mean annual limits.
Yeah, do you know? Yeah, you're right. But both of you right. But do you know those limits for under 18? It's 6 millisieverts.
I know
okay?
from above 18 should be not exceed 20 millisieverts. So under
Yeah, but
18,
under
sure it is
under
less.
18, yeah, it's 6 millisieverts. Okay.
6, yeah? Oh.
6 millisieverts. Applying this definition to
Okay.
radiological, this is just more a clarification of a controlled area. If you just go to hospital X-ray rooms, it can be classified as controlled area. Okay. In order to avoid uncertainty about the extent of controlled area, physical border should actually be there, and doors, wall, fence for controlled area. Example, because you care about the industrial, it's example of controlled area associated with the nuclear gauges are around the portable gauges inside the portable source stores, annual fixed, around fixed gauges during some maintenance operation. And we have image actually to explain the controlled area, this kind of things. And this is just example about the controlled area associated with the well logging around the borehole head during use, inside the source store, around the logging tool during source loading operation, around the source container during transport of equipment. This can be classified as a controlled areas. From the definition of controlled area, you can actually define the controlled area, and as RSO, you can help to make or identify the controlled area. Individual monitoring required for all those who access controlled area. Records for individual monitoring must be kept. Purpose of monitoring is to demonstrate that exposure are adequately controlled, because sometimes even in controlled area, the radiation level can be higher, okay, with the time. So you have to keep monitoring people inside the controlled area. It's not just classify this controlled area and just forget it, okay? So you have to revise it, okay, from time to time to see if there's something, the radiation exposure condition, change it or not. This is one of your mission as a RSO. Person under 18 years in age should not be classified as a category A or B worker. Effective dose for those aged under, we told you about this one, the 6 millisievert. Once the pregnancy has been declared, the working condition of the pregnant work should be managed to prevent the likely of, you mean to try to keep the dose as low as possible. It's similar to public dose limit for women, but it's not to stop pregnant woman or pregnant worker from work, okay? Controlled area requirements. It requires local roles to control this area. Demarcation, restriction of access, monitoring, posting, and we will see which one. Work in controlled area must be carried out according with the written law, and this is also done by RSO and the employer, okay? You should have local roles, which is depends actually on the international one. And the ultimate goal is to achieve the radiation protection. So you have to have in person responsible supervising this the work to be able also reviewing from time to time. Description of the controlled and supervised area. General radiation safety measures should be actually be there and written. Dose investigation level, emergency plan. Access to the control area should be restricted, and there are some requirements, protective clothes and equipment. So sometimes you will use radioactive material. Okay, so you have to have specific or special clothes to protect yourself from the contamination. Monitoring equipment like TLD or servometer or pocket dosimeter or area monitoring to just make sure you are working in safe working condition. Suitable storage for personal clothing, just to avoid also to contaminate your clothes. When you use controlled area, and to go out is not also, I mean, there's some requirement to go out of the controlled area, because you have protective clothes and you will touch some radioactive or you contaminated to radioactive material. So you have to make sure you are not contaminated, and should be there washing or showering facilities, okay, to also to remove any residual radioactive materials. Suitable storage for the contaminated protective, like gloves, okay, because the gloves, contaminated gloves, it's kind of radioactive materials, and used to be you have to deal with this kind of contaminated clothes as a radiation source, okay, so you have to be careful, okay. Within the controlled area, it is often necessary to define region, even inside controlled area, where compliance with the relevant limits can be achieved only by limiting the time spent by the worker in the region, because controlled area, maybe in some area inside or region inside the controlled area, different activities there. So, for example, one region has higher exposure dose than others. So you will ask the worker in this region to work with the less time there, okay, to achieve the radiation protection using the special protective clothing, other protective devices, For the purposes of such special control as may be necessary, employer should identify areas of high radiation level, high airborne contamination, or high service. And this you will use actually sign for that, even inside controlled area. So we have two classifications: the main controlled area, I mean radiation area, controlled and supervisor. Inside the controlled area, if there are different activities there, you have also to classify that area as RSO with employer to put some measures and requirements to make use of this kind of regions. You have to revise the working condition there and work, and you will have to record the exposure dose for the worker to determine the possible need to revise the protection measure or safety provisions or boundary controlled area. Why boundary controlled area? Maybe if the activities inside increased or the exposure, because you have to measure the exposure out of a controlled area. If you notice the exposure out of the controlled area is higher than it should be included in the controlled area, so maybe that time you need to extend the controlled area to include wider region. Posting the controlled area. All areas containing radiation hazards or having the potential to contain radiation hazard will be posted with the appropriate sign. The employer, with the advice of the RSO, should normally define the controlled areas by warning sign and should be clear at the entrance of the area. Used to just make kind of alarm for people, okay, about this area, about the risk in this area, and should be by RSO and employer to be updated. Any posting must be clear, legible, noticeable, posted, and may include radiation protection instruction. We will see some sign and you will understand what I mean by that. Contain the standard radiation sample colored. Black one is the famous one. Magnetites used in American, I think, but both of them used actually with the yellow background. This is the main warning sign. Should include this radiation symbol. Such additional inscription or symbol as are required to indicate clearly to all concerned of the magnitude and particular nature of exposure risk. You need to have this sign and write down, this is controlled area. This is one of, to make it more clear. And also contain in this post or warning sign, contain this is contaminated, this is activity, radioactive material here or X-ray. So you have to define the area, controlled area, and define the activities. Okay, this is just example how to control the exposure by divided the areas when you work with this kind of radiation and nuclear gauges. And this is the sign. If you see here on the left side, the left sign is controlled radiation. Why this is working? Okay,
Hello, excuse me, I have a question.
yes, go ahead.
I saw a slide about local rules. Of course, we are getting information about the rules. For example, what we have to do in case of an accident, and the things like that from the training that we are getting from this kind of training. But actually, I want to know that from where we can print the local rules. That is the obligation of a contractor to the public, and things like that. That the people.
Excuse me, the sound is actually it's not clear. Hello? I couldn't hear the rest of question.
Yeah. I think you can hear me now, please.
Yeah, now it's okay.
Yeah, okay. So that the under 18 years old, there should be maximum 60 millisievert. All this information we are getting from the training only. From where we can print, and we are getting the RSO responsibilities also from the website. But from where we can find out the total local rules or the legal obligations of the contractor from the government website.
Yeah, if I understood your question, okay, we have here in Saudi NRRC. This is organization here in Saudi Arabia that control the radiation protection in Saudi Arabia, and you can get the information from there. And there is something you call international. This is, and what I mean by local role depends on this kind of dose limit or something. You will have your internet is not good connection. Anyways, you have local role. I mean, every organization or let's say companies, or they have different activities. Okay, they have different conditions. Okay, so if you have, for example, in controlled area, you have high activity source in controlled area. Okay, and you have, for example, 10 persons, and they have they should have working in this area, and this area is small. Okay, so you will have local roles, okay, to control people here. You will not be able to let them all go there. Okay, so you will have to control the exposure by reducing the number working in this area. But actually, you are also following the main roles, I mean national roles by NRRC or by IEA. You have to follow this, okay? But what I mean by local, this is what I mean, yeah. So you will have a special condition in work, yeah. So if I answer your question or you.
Yeah, I understand that, that you mean here is local rules. Okay, thank you very much for that answer. But actually, I want to know something about the other thing also. Just like our labor law, okay, it is regardless of any condition, everybody has to follow labor law. Like that, if any kind of radiation activities, there should be a general law of Saudi government. We go to NRRC website, but we could not find it actually. Okay, I think Jafari, you can explain this one a little more, because we searched for the general labor law or the legal obligation of a radiation contractor, and we could not find it. Jafari, can you explain this one, please?
Yeah, okay. Anyways, also, I don't know about their website, okay? But if you will go there, I mean, as an organization, they should answer you about this, and they should provide you with the, when you get the license, I mean, the organization or companies, when they get license, they have requirements, and companies should follow this requirement, okay, to get the license to practice radiation work. So during getting license, okay, they will give you this kind of roles. You have to follow this role. You have to during licensing, okay. But anyways, through ICRP or through IEA in the website, there is many guides, okay, for occupational exposure, for pregnant, for different radiation workers, okay, recommendation by IAA. Okay, so you can find the information there. And I think NRRC, I'm sure they follow also this kind of role. They will not be different. Okay.
Okay.
So if you go directly to IAA, you will find different guides there for medical application, for industrial application, for occupational exposure. Everything's there. So we can get the information there. Okay.
Okay. Thank you. Thank you.
You're welcome. You're welcome. Radiation controlled area, the sign, I just try to explain the sign. What sign should include? Okay, radiation controlled area. This is controlled area. It's mentioned in this sign. And this is the main radiation sign, should be also there. Risk of the contamination. This is more description. Okay, this is more clear actually. And no entry except authorized person. All this sign contain all information needed. Okay. And this is the same thing, radiation of risk of radiation. And this is just another type of sign, caution or warning sign. Controlled work area, radioactive material. So just to be familiar with this kind of sign. Supervised area is just the area where the dose, it's just the dose there. Supervised area, area which we don't expect the exposure or occupational exposure condition need to be kept under review, even though a specific measure for protection and safety are not normally needed. It may be convenient to define the area where the condition or exposure there is just less than 3/10 of any annual dose. Okay, or actually it's around 1 millisievert. Example of supervised area. Simply, we can say the supervised area is just around the controlled area. Okay, with the nuclear gauge, in industrial application, around fixed gauge, gamma or beta. In hospital, for example, the area surrounding X-ray rooms, the control room, it can be supervised area if the dose is around 1 millisievert or less. Mark the supervised area by the appropriate sign is one of requirements. Display warning sign at appropriate axis in clear place to show people this is supervised area. And also, as what we did with the controlled area, the review should be done actually frequently to make sure the condition is still the same. If the exposure dose or the radiation level increased in this supervised area, so another measure should be taken, maybe part of, for example, if we have X-ray room on hospital and we have controlled room is the X-ray room and the supervised area is the control room, okay, outside of X-ray room. But if something happened and the radiation level increased in the control console or control room, so we have to revise it and make it as a controlled area, not supervised area. The access of radiation worker to supervised area should be subject to local operation instruction provided by the employer and RSO. The access of radiation worker to supervised area should be subject to, this is what we said, I think it's just repeated. This warning sign the same way, actually, the warning sign should include the radiation sign and also description the same way of controlled area. This is the radiation supervised area. The sign also include all information, all needed information, just to show people you are in supervised area, you are in controlled area. Okay. Area should be monitored by radiation detectors. Just also this will help when you review the measure and condition in this area. So you have to have area monitoring in supervised and controlled area to avoid just the radiation level, to make sure the radiation level is not changed. Record of monitoring should be kept. This will help actually RSO and employer to revise and review the measure in this place. Purpose of monitoring is ensure that radiation level remain within expected limits. And this just summary for who want to have simple just way to distinguish between controlled area, supervised area, or non-designated area. So this will help you just summarize what we talked about it. And thank you so much. And if you have, we have time actually for questions. If you wanted to ask, we have half an hour. I think I was fast, so we can revise any slides if you want, or if you have any question about any one of these lecture. Radiation detector classification.
Regarding this radiation dose records, how many years we have to keep actually the records of the radiation things, radiation files?
Actually, to be honest, I cannot remember that one, but I can actually send your the answer.
Thank you.
I have to back to that one too. Yeah, sorry.
Yeah. Actually, these are the things we need from the local. I mean, the government rule actually. Okay, a lot of questions like this we can get. Actually, we tried in NRRC, but we could not find a legal register or something like that, or Saudi Arabian legal obligation. Okay, maybe it is somewhere. Okay, so please, if you have, you can share with the total document.
Yeah, I can, because I remember this one. Okay, I can. I just cannot remember the figure now, but I have this one, and I will try to send it to you. And then
Okay.
RRC, I think they just started just a few years ago, so I think they will provide this kind of things, and I recommend you to visit them. Okay, it's not just depend on the website. So if you will visit there, you will find actually more information.
Okay. Thank you.
You're welcome. Any question? Radiation detectors, classification area, or personal detectors? I will ask you then. What is different between survey meter and the, or is there any difference between the survey meter and detector for detect contamination? You have answer?
Survey meter is exposure rate, and detector is detect the radiation. What kind? Their alpha radiation type is alpha, beta, gamma, or neutron. Should be like.
If you are a SO and employer told you that there is contamination in some area in your companies or your work area, what kind of detector you will use to check the contamination?
The survey meter. Survey. No,
Yeah.
detector.
Yeah, it will be detector, but what kind of detector? It's Geiger.
We can
And
use
what kind of radiation?
Neutron detector
Sorry?
also. We can use neutron detector also.
Okay. Any other answer? Contamination.
Then,
Yeah.
if you
Go
are
ahead.
finding a contamination or a leak for a particular equipment, of course, we will make leak test. Okay, this is another way to control the leaking and cause of contamination.
Okay, if you have, for example, liquid or on the surface, I mean, it's not the leakage from X-ray. X-ray, it's something different.
This, okay, iodide, what is that? What type of that detector? This using the iodine solution for the contamination of the workplace.
Anyways, for contamination, surface contaminated, so you will need alpha or beta probe to detect this kind of contamination. Okay, connected to the different type of detector of Geiger or scintillator. Okay, to sense the alpha or beta, because if you will use surveymeter, you will not be able to detect the contamination. You have to
Surveymeter
take
exposure rate, right? It is. You can see.
Yeah, it's exposure rate. Yeah, but it will measure gamma or X-ray. Okay, it cannot measure the beta or alpha.
Yeah, but
alpha needs so you have to have swap.
The mainly, the alpha beta is only you can control even by the paper. That's why they are not giving too important there. But risk factor is more than the other radiation, alpha and beta.
Yeah, but it's easy to detect the gamma or X-ray by surveymeter.
Yeah.
But contaminated surface, for example, if there is some material on surface and someone touch it and eat something, it will be more dangerous. Yeah, it will be more dangerous. Alpha, when intake inside the body, it will kill people. Okay, so even this one you have to check. Okay, but using surveymeter, normal surveymeter, it will not help. Okay, so any suspect material, you have to have a specific probe to detect alpha or beta. Okay, because it's not easy to.
Can you give name the what type of probe that we can use for the?
Yeah, it's kind of we call it Pancake Probe. This is for alpha, and it's kind of different. Okay, you can use scintillator or yeah, but you can say alpha or beta probe. That's it. It's
right
easy
now.
to
Now is much modern for equipment have to detect the specific probe for a specific radiation.
Yeah, but in general, okay, if you will go deep in detectors, you will find a lot of information. Okay, but in general, and the same information is almost the same mechanism. Okay, it's just different sensitivity, different efficiency. It depends on the source you have. Okay, so when you wanted to buy detectors, you have to know what you have. Okay, what kind of source you have, what kind of radiation you have, what energy of radiation you have. Okay, so it's not for example, if you have low energy source, you need to buy proportional counter. Okay, to sense this kind of radiation. But ionization chamber, it will not be that useful. Okay, if you need sensitive detectors. But if you have high energy, high penetrating radiation, you will need maybe semiconductor detector or proportional. It's different detectors you can choose according to your radioactive source or your machine. Okay, so it's not easy to buy, and there is no detector for any one detector for all radiation. Okay, you have to be specific actually what you need. If you need sensitivity, high sensitivity, or you have efficiency, or you don't need efficiency or sensitivity. You need just to surveymeter to just sense radiation. Yeah, it's just depends on your application. So if you go and buy one, they will ask you this kind of things: what kind of radiation, what kind of activities, what kind of energy. This information, it will help to choose the right detector. If you don't have more questions, still we have time. It's your time, so if you don't like anyone is wanted to ask question, I'm here. If you don't like to spend more time, you just leave. It's up to you.
Yeah, actually, one more question. Okay, we are getting the dosimeter report. Okay, yeah, HP 10, that is the 10 millimeter, and HP 07. So when we are counting the millisievert for the total year, normally we are counting only the HP 10 only. That is the whole body count. We can ignore the HP 0.07. Right, because we are getting both readings. Yeah. Okay. So
Actually,
can,
Go ahead.
Yeah, we can consider only HP 10 only, HP 10 reading only, right?
It's the more important is the whole body. It's HP 10, okay. But we have to have mentioned two reading, okay, shallow dose and whole body. But we care actually with the deep dose or whole body, HP 10.
Yeah, when we calculate the total dose, we will calculate only the HP 10, right? For the year.
Yeah, that's right. Yeah.
Okay, thank you.
Yeah, okay. You are free to leave the meeting. Anyone doesn't have any question?
Thank you, Mr. Fad.
Thank you.